Okay, y'all, so let's go through and talk about quadratic functions. I know we've talked about those before, but let's just kind of do a quick review of the things that we know about quadratics. So first of all, standard form for a quadratic is y equals ax squared plus bx plus c, where the a value tells you if it opens up or down. If a is positive, it opens up. If a is negative, it opens down. The c value represents our y-intercept. Okay, so that would be the place where it crosses our y-axis. Remember that quadratics have a vertex. So to find the vertex in standard form, the x of the vertex is negative b over 2a. And then to find the y of the vertex, we would plug in the x and find out what the y value is. Okay. We also have what is called vertex form. So y equals a times x minus h squared plus k. This vertex form is really nice because if you've got vertex form, then the vertex is just the hk, which is super nice because that makes it really easy to see versus in standard form where you got to do some work to find it. The A still represents whether it opens up or down. In this form, you can't see the y-intercept as easily, but you can go through and find the y-intercept because you know a y-intercept would be when x is 0, and you could change x to 0 and solve. But it just depends on the form that we are looking at. So we're going to go through and look at a couple of different examples to go along with these. So I might have f of x equals 2 times x minus 1 squared plus 3. And when I look at that, I can tell that this graph is opening up. Okay, so if I'm describing it, I'm going to say it's opening up. I can tell that the vertex is at the point 1, 3 based on hk. Remember that what's in the parentheses, just like in transformations, looks opposite. So it looks like it might say -1, but it's really saying +1. So I could plot my vertex on here, 1, 3. Hopefully I can get it in the right spot. And then I might want to go through and find some other information. So I might go through and say, I'm going to make me a little table for x, comma, y. And I'm going to choose something on one side of that vertex. Like I'm going to choose 0. And if I go up here and I plug in 0, 2 times 0 minus 1 squared plus 3, I can do that in my calculator. I can do that on my own, however you want to do that. I'm going to get 5. So I know I have the point 0, 5. Now, remember that quadratics have symmetry. So at my vertex, I have what is called the axis of symmetry. So the axis of symmetry in this case would be x equals 1. It's a vertical line. And that x equals comes straight from the vertex. Well, that helps me because I know that if I've got a point at 0, 5, which is 1 unit from my axis of symmetry, then I also have a point at 2, 5, which is 1 unit on the other side of my axis of symmetry. And I can go through and find more points. I'm not in this particular case. And then draw the curve of my quadratic equation. Now, also notice some other information I can see here. I can see that my y-intercept is the point 0, 5. Didn't ask, but I can see it. I can also see that I have no x-intercepts in this particular case. So there are none there. Okay, let's look at this form. So this is standard form. I can't look at this one as easily and tell my vertex. I can tell that this graph is opening up. So because I know that this graph is opening up, that's going to kind of help guide me. And then to find my vertex, I'm going to do x equals -b over 2a. Remember that this is in the form ax squared plus bx plus c. So I can go through and say, all right, -b would be -8 over 2 times 2, which -8 divided by 4 would be -2. All right, so under the x So my vertex is -2. And then I can go and say 2 times -2 squared plus 8 times -2 plus 7. And if I went through and did that, I would have that my y value would be, let's see, -1, I believe. I got 8 minus 16 plus 7. Yeah, so -1. So I can see that my vertex is at the point -2, -1. And I know I could go plot -2, -1. I also know that I have an axis of symmetry. My axis of symmetry would be that vertical line that goes down through there. So my axis of symmetry would be x equals -2, so coming from the x of the vertex. Remember, just before, I can go in and I can find other points. In this case, remember we said C represented the y-intercept. So I know the y-intercept is at 0, 7. 1, 2, 3, 4, 5, 6, 7 right here. If that's 2 units from the axis of symmetry, I can go 2 units on the other side, and I've got a nice point to my parabola. Okay, I may want to go in and find some other points, like if I went and put this in this equation in y equals and went graph and then second table, it would tell me that -1, 1 would be a point. It would tell me that -3, 1 would be a point. So I could get a lot of nice other points. What it would also show me, in addition to, like I said, my y-intercept, is that I have 2 x-intercepts. And in this particular case, to find most x-intercepts, or what we call zeros, I could go through and go second trace and look at zeros in there and look at that left bound and right bound. So we could use that. We could also go through and find our x-intercepts a different way. We could go through and use the quadratic formula. So if you needed to go through and try the quadratic formula in order to verify what your x-intercepts are, this might be a good place to go through and do that. We'll talk more about quadratic formula later, but if I were going to go into my calculator, I would just go type y equals, and then I'd type in 2x squared plus 8x plus 7. And then I would go through and press second trace. And I'm doing this because I can't get a calculator pop up. I can do another video later with that on there. But if I press second trace, I can look at number 2, I believe it is, that says 0. And if I do that, what will happen is it will pop up something that says left bound and right bound. And I can go around this point, because that would be an x-intercept, which is also known as a 0. And I could go a little to the left, a little to the right, and then it would tell me that 0. And then I could do that same thing again to get the other 0. I know they're pretty close to -1 and -3, but I don't know exactly what they are without doing that in my calculator or with my quadratic formula. Okay, so I think that's kind of enough to give you an idea about working with quadratics, and then we can go on and talk about some higher order polynomials. Move this thing. Stop.